5.1 Trig Identities. In this next section, we're going to talk about the different trig identities and how to simplify expressions using those identities. So the first concept I want to talk about is the reciprocal identities. These should look pretty familiar. It's just that sine is 1 over cosecant, so cosecant's 1 over sine. Cosine's 1 over secant, so secant is 1 over cosine. Tangent is 1 over cotangent, so cotangent is 1 over tangent. This basically just says that if you flip cosecant, you get sine. Same thing goes for these. If you flip secant, it turns into cosine, and so on. The next identities I want to talk about are the quotient identities. We've already looked at this and used these identities to solve problems, but we have tangent is sine over cosine, which would make cotangent cosine over sine. Notice that tangent is the reciprocal of cotangent, so all we do is switch these to switch between tangent and cotangent. Okay, example 1. If cosecant of theta is equal to 7/4, we want to find sine of theta. Now this shouldn't be too tough, but we're going to write it out algebraically. So I know that sine of theta is equal to 1 over cosecant theta. And I know that cosecant theta is 7/4. So then in order to make this go to the numerator, you're going to take the reciprocal. So this is 4 over 7. This might seem like a lot of work, but basically what you do is if you have cosecant is equal to 7/4 and you want sine, you just take the reciprocal. So this 4 goes up top and the 7 goes to the bottom. Alright, let's try another one. If cotangent of x is 2 over 5 square root of 5 and sine of x is square root of 5 over 3, we want to find cosine. Okay, so let's first try to think of an identity that relates cotangent with sine and cosine. So remember that cotangent of x is equal to cosine over sine. Okay, so now let's plug in what we know. We know that cotangent of x is 2 divided by 5 radical 5. And we don't know cosine, that's what we're looking for. And we know sine is the square root of 5 over 3. So again, I'm going to clean that up just a little bit. This is 2 over 5 square root of 5. I don't like having a fraction within a fraction, so I multiply the numerator and denominator by 3. It's going to cancel these, and I get 3 cosine of x divided by radical 5. And now my goal is to get cosine all by itself. So I'm going to multiply both sides by radical 5 over 3. And then these are going to reduce off. And I'm left with 2 divided by 15 is cosine. So my final answer, cosine of x, is equal to 2 divided by 15. Okay, now on your own, I want you to try these two problems. If secant of x is 5/3, determine cosine. And if cosecant of beta, so this is beta right here. Beta is just another letter we use like alpha or omega or theta. These all represent angles. Is equal to 25 over 7. And secant of beta is 25 over 24. Determine tangent of beta. So go ahead and try this on your own. Alright, so if we have secant of x is 5/3, then cosine of x, this is really easy, is just 3 over 5. All you have to do is take the reciprocal. That's it. Okay, so now we're given that cosecant of beta is 25 over 7, and secant of beta is 25 over 24. So before I even start worrying about what I want to find, I don't like working with cosecants and secants, so I'm going to write this as sine of beta is 7 over 25, and cosine of beta is 24 over 25. Now I know previously I've taught you how to do this by using triangles, but now I'm going to show you how to do it just using algebra. You can solve them either way. So I get tangent of beta is equal to sine over cosine. So my sine was 7 over 25, and my cosine was 24 over 25. So when you divide a fraction by a fraction, you multiply by its reciprocal. And so you get 7 over 25 times 25 over 24. These reduce off, and you're left with your answer 7 over 24, and you're all done.